Okay, last lesson we ended talking about finding the approximate volume over this region R, which happened to be a nice rectangular region. We'll eventually get to more interesting, more complicated regions. But for now, we're just going to start with rectangular regions. This one happens to be a square. And then under this, so over that region, under this surface. So we're always going to go from a region in the XY plane to a surface from a region in the XY plane. Maybe that surface lives below, or maybe partially below and partially above. And then we want to get a volume of that. And we're going to start by approximating that volume. And we did a couple by hand. Maybe I'll do some small ones, no problem, just like you did back in R2. But beyond that, we're going to use some tech tools that computers love to program algorithms. Computers aren't good at creating algorithms. That's what you're going to get good at by understanding the concepts of creating things. But computers love to take it from here. You make an algorithm and they'll run it. So let's use a tech tool to do that. And a really nice one that also visualizes, as usual, is CalcPlot 3D. So okay, so CalcPlot 3D, this was the sleeping bag surface we were looking at over 0, 1 in the XY plane for X and for Y. So it was a square in the XY plane. And then we had this surface over top of that, which we said sort of approximated Chiche's sleeping bag. All right, now we want to get the volume of that. So there's a way to do that. Let's turn this off and let's select a region, because again, this is the key term for us, is a region. And then let's look what happens on the left side here in CalcPlot 3D. So it starts with the preset region. We want our region Y goes from 0 to 1 instead of 0 to a function. And then we want X to just go from 0 to 1. All right, so now we see, you want to check what you have here, this little purple region on the left side. That's correct. We wanted it to go from 0 to 1. And now we'll work on the function. So the function we were looking at was the square root of X times Y. Cool. So now it shows that sort of sleeping bag surface a bit better. Again, use your arrows to get better control here. There we see it from directly above. Okay, now some things you can do. It shows so again, we wanted to go from z equals 0, which is the XY plane, that's the part here, to the surface. We can show the Riemann prisms. And then this is really cool because it also, besides showing them, computes volumes. And so let's take a look now. What's neat too, those are the Riemann prisms. Over here on the left, it divided it, you have control over how many prisms in each direction. We had just done 2, right? So we did a really gross approximation by hand. And then look at the yellow region here. It does split it into those 4 squares that we had worked on. And again, it shows the prisms through the surface. So it looks like some are underestimating, maybe some parts of it overestimate. It's hard to tell, but just with 4, maybe it might actually do a decent approximation. So let's go ahead and change some parameters here. You can change, there's our options for lower left, lower right, upper right, 5 different things, and those are the most common. The midpoint, again, usually the best bang for the buck, so we'll do that one. And then this neat little feature show the points used for the heights. And the volume it's estimating as 0.466 with just 4 n equals 4 rectangles, 0.466. So let's see how close we will be. And just to show you those black points, those are the heights that we were computing. Those were f of x, y's that we were getting. It's showing you where they would be, as opposed to had you chose, say, the upper left, it would use these 4 points. 1, 2, 3, 4, yeah. And again, notice that some of those are also 0, the purple for the prisms. Some of those in the back here didn't compute any prisms because the heights were 0. So that's another advantage why the mid rule works better for this particular instance as well. Okay, oh yeah, you can see them from underneath there too. Points in the XY plane up to the surface. Okay. Okay, so we're trying to now increase, we see that we can use different rules here, and we want to increase the number of rectangles. So we can increase, maybe we'll do 8 in each direction. Look here how many more little rectangles we have, and it's still showing all those midpoints. Maybe let's get those off there for a moment, clean it up. So we'll have 64, n equals 64 at this point. Let's look at the, we can see we do a much better job approximating the surface, the volume of the surface with the 64. And let's go ahead and see what the volume approximation, 0.447. Let's maybe ramp it up even more and see how good we can get. Watch the volume at the bottom of the screen. If we're doing maybe 20 in each direction, we're getting 0.445. Let's just keep on going. Let's see what we can, how good Calcplot 3D can be. Let's not show the heights. There's too many little black dots there. It's stalling it, making it take some time. Okay, and again, we see like we can, this tool will do it. There's other Wolfram Alpha you can ask to do it too with approximate volumes, and then we'll eventually get to exact volumes very soon with integrals, and we'll see just how good our approximation. So here we're about 0.445 when we had n equals 20 by 20. Oops. Okay, so it looks like we stalled out on Calcplot 3D trying to make it do like n equals 50 by 50, so 2,500. Too much for that. But play around with that, and I think you'll see the visualization will definitely help you when you're doing some of these by hand. You have to be able to do a few by hand to understand it in case you wanted to create your own methods eventually. So work those by hand and then check your work visually with Calcplot 3D. Have fun.